Hola humans! Today we're going to simplify radicals with fractions. So the steps we're going to follow are reduce your fraction if possible. That will make all of your calculations a lot faster if you're able to do this at the beginning. The second thing is we're going to apply the root symbol to the top and bottom of the fraction. And then we're going to rationalize the denominator because we want whole numbers on the bottom only. And then if we can simplify the radical or simplify the fraction, we'll do that. All right, looking at example 1, I see that we have the fraction 7 over 3, which cannot be reduced. So we're going to jump straight into step 2, and that is to apply the root symbol to both the top and the bottom. From here, we're going to rationalize the denominator, and we do that by multiplying by whatever my bottom square root number is. So if I have the square root of 3 here, I'm going to multiply that to the top and bottom. And all this step is a clever way of multiplying by 1. Right? If I do 2 divided by 2, I get 1. 10 divided by 10 is 1. 1,000 divided by 1,000 is 1. Here, square root of 3 divided by square root of 3 is also 1. So it's a clever way of not changing the value of the fraction. But whenever I multiply, at the bottom, we have 3 times 3 underneath the square root because we multiply the numbers inside the radical together. And we know that when we have a pair of matching numbers, we can bring those outside of the square root. So now I can bring out that 3 and there's nothing left inside. Looking at the top, we have 7 times 3, which is 21. I notice that both 7 and 3 are prime, so whenever I write square root of 21, I can't simplify that. That top number will not have any pairs inside. So this would be my final answer for example 1. All right, looking at example 2, 18 over 25. I cannot simplify that fraction. They're not both even, so I can't divide by 2. So moving straight on to that second step, we're going to divide square root of 18 by the square root of 25. So I'm applying that root to the top and the bottom. And then we're going to try and simplify this. If I did the square root of 25, well, I know right away that the square root of 25 is already a whole number, which is 5. So this one is super easy, yay happiness, because I don't have to do that rationalizing step where I multiply by the top and the bottom. The square root of 18, that one we might be able to simplify. So I'm going to bring that over here and we're going to try and break that down. So the square root of 18 could be 2 times 9. 9 could be broken down into 3 times 3. So when I organize these numbers, 2, 3, 3, I can bring out a pair of 3s. So this would be 3 square root of 2. So I can put that up here in my numerator and I am done with this problem because 3 over 5 cannot be reduced. All right, looking at example 3. Here I see I do have 2 even numbers inside the square root. So I can reduce this fraction. 22 divided by 2 is 11. 10 divided by 2 is 5. And now I'm going to go to that second step and apply the square root symbol to both the top and the bottom. Looking at this one, 5 is prime, so I can't simplify that. 11 is also prime, so I can't simplify that with the radical. So I'm going to go into my next step to rationalize the denominator. So I'm going to multiply by the square root of 5 to the top and the bottom. That way, in my denominator, I have 2 square roots of 5, which allows me to bring that out, and I would just have 5 as my denominator. On the top, we have 11 times 5. So that would be the square root of 55. Kind of the same thing. I can't break that down into anything that's going to have pairs. So the square root of 55 over 5 would be my final answer here. Looking at example 4. Now we're getting into bigger numbers. I am seeing right away that these are both even, so I want to try and simplify this fraction as much as possible. So when I'm looking at this one, if you struggle with these, I would get your calculator out if you're allowed. Okay, and I know some things about 48. So I know 48 is divisible by 4, might be divisible by 12. Those are numbers I have in my brain. So I want to see if I can divide 300 by 4. 4 works. So if I divide the top and the bottom by 4, I can get 75 on top. I can get 12 on the bottom. And then I want to kind of keep going. 75 over 12. Well, it doesn't look like 2 is going to work, but I know 12 is 4 times 3. So I'm going to try dividing both by 3. Okay, for that top one, I get 25. For that bottom number, I'm going to get 4. 12 divided by 3 is 4. And from here, I don't think there's anything more that I can reduce. 25 divided by 4 is a decimal, so there's nothing I can do here. So this is going to be my starting point, which is a lot nicer looking than this 300 over 48. So when I look at this, I am actually working with the square root of 25 over the square root of 4. And if I apply my square roots here, I know the square root of 25 is 5. I get a whole number. The square root of 4 is 2. I also get a whole number. So now I'm done. All right, and example 5. This is going to be dealing with cubed root. So I have a little 3 at the beginning. If your teacher's assignments are only with the square roots, feel free to pause, but we are going to move forward with example 5. All right, so with this one, we are thinking about pulling out triples instead of squares, but our process is exactly the same. So when I'm looking at 250 over 18, I again want to try and see if I can reduce that fraction. I see that the top and the bottom are both even numbers, so I'm going to see how 2 works. So I'm going to do 250 divided by 2. And I get 125. And then 18 divided by 2, I know that that is 9. I'm going to try 3. So 125 divided by 3, that does not work. I get a decimal. 9, the only thing that can go into 9 is 3. So this means that this fraction is simplified as much as it can be. So instead of breaking down 250 over 18, we're going to break down the cubed root of 125 over 9. Okay, so going with that step 2, I'm going to apply the root to both the top and bottom, but this time don't forget to write that 3 in front. So I'm going to have 3 over here and 9. With these, I want to see if I can break up the cubed root of 9. So if I try and think of what that is, I have 3 times 3, but that's it. That's as far as I can go. So I'm not going to have any triples here at all. So now what I want to do is think about a way that I could get 3 matching numbers on the bottom. Okay, well, you've got 2 different ways to do that. I could say, hey, I've got 1 9 here. What if I multiply by 2 9s over here? If I did that, now I have 3 9s inside the radical, and I could have 9 as my whole number over here. The other option is to recognize that this 9 right here is the same thing as 3 squared, 3 times 3. And 3 times 3 means that I have 2 3's under the cubed root. So if I multiply by 1 more 3, now between these two, I have 3 3's under here, and I can bring out the whole number 3. So these become tricky, but the better you are with your multiplication, the faster these will feel. So I'm going to work with the cubed root of 3 because those are smaller numbers. So that means I'm also going to multiply my top by the cubed root of 3. Okay, so we already know that we have the whole number 3 at the bottom. For the top, we have this 125 times 3. And we know that that's going to be a large number, so we want to break that up. For our notes, I'm going to go ahead and multiply and just write that number here. So that is 375. So the number that we are going to break down is that 375. Okay, so moving over here, we're going to break down that cubed root of 375. And we already know that 3 times 125 works for this number. So 3 is prime, 125, we can break that up. And if you are needing your calculator, definitely feel free to use that to break down if you are allowed those in class. So 125, divide that by 5 is 25. I know anything that ends with a 5 is divisible by 5. And I also know with 25, that is the same thing as 5 times 5. So looking at this one, we have broken it into 3 times 5 times 5 times 5. And this again is under the cubed root, so I need triples, which I do have. I have a set of 5s that I can bring out. So I have 5 times the cubed root of 3 for my top number, which means over here, I can say that my final answer is 5 times the cubed root of 3 over 3. And we are done.